Hello everyone, welcome to yet another video, and this time is about LINQ in Linux. So before we dive straight into it, first we need to understand the concept of files. So basically, let's say you have a file, stuff like that. So a file, there's two parts of it. Well, essentially two part of the files. So say first one is gonna be your label, which you name this, let's say file 1, stuff like that. And the second, which is the most important thing, is the inode. Now what exactly is the inode? So essentially what you need to know is that every single file on our systems all have inode to represent it. So basically, say every single file on your system, like say file 1, 2, 3, 4, 5, stuff like that, in our systems is going to have its own inode. Now the inode does not contain the content of the files or the label or the name itself, but what it do contain is various information about that particular files, and very useful one of that. So basically it could contain an inode number, which of course is essential, file size to represent how much file does it take, how much space does it take, on the informations, permissions, what type of file that is, and the numbers of link it has, etc. There's few other more as well. For instance, you can even look this up. So let's say I'm going to my command and I type, I'm looking for some files. Now, I'm not sure if I have some file. Now let me just create one like here. So I'm gonna go, I want to see if my files have any files. Does take one files, okay. Now I want to access that file right here. So ls. Now you see if I type like this, it doesn't really show that. So it does show some information on where it's exactly located on a hard drive. Now if I type ls and then a to dash li, which stands for inode, you could see that this file, particular file right here, it's show as inode right here. So these are all inode numbers, okay? And these are the number that represents the spot or location and where your particular file is located, and not the content itself. Now that we get out of the way, let's go on to the link. Now there's two types of link here. There's hard node and then soft node. Now first one we're gonna get into is hard node. Now basically hard node is basically like a copy of files or a mirror file. Now what does that mean exactly? Now let's say here I have two files. Let's say if I have file 1, f1, let's just call it that. Now I have file 2, f2, and this file right here, I'm gonna link this file right here, and I'll put this in a specific location that is inode, representing that specific location on our systems or disk drive. So as you can see here, these files here have different naming. So this is file 1, file 2. Technically they are both separate files, but they are all linked to the same locations, same files. So technically they could have the same size, same content, as well as the same inode on that location. So what does that mean exactly? So I'm gonna here, let's clear this up, go here, and I want to search, I want to link something. Okay, so let's go back here. I want to link two files. So I'm gonna create file, let's say one file, file 1, txt. Actually, you should create two of them. File 2, let's say file, some files, txt. Okay, and then now I can link those two files. So to link files, just say ln, which stands for link. Now if I want to say the source files, which is, let's say file 1, or let's say, you know what, say some files, that will make more sense. Some files.txt, and then the second we'll name our file 1 txt, which is our link files. Now this is the source file, but technically they are two files. So do that, and oh, actually that file exists. Hold on, let's modify that. Do that. Okay, now you see here that didn't work because this I create this file already create, so you cannot do that. If it already exists, you just gonna remove it. Actually, hold on. There you go. Now we'll ls. I'm going to link my file here. ls file1, that's txt. We have source file and our link file. I'm going to name and create this file2 in inters. Now when ls, see ls, and then see our eyes, which might already show our node numbers, inode numbers. Now you see here, file1, file2, they both has the identical inode number. Now it's two name, files two have different names, but the size here, you can check it out, so 0, 0. Now, let's say I want to modify a file. So let's say file1, that's txt. Modify that file. Let's say, hello, my name is, okay. Area can type. Okay, and when I save it, say save. Yes, enter. Okay, now when you ls again, you see right here 39 and 39, so they have the same exact size. Now why is that, you wonders? Well, obviously because they have the same contents. Let's say equal cat txt, it has that, but when I equal cat files 2, that's txt, has the same contents. Okay. Now for hard link, if you remove one of them, your files still safe. Because now say I remove a file1, which is right fine, txt. Now when you look ls again, you see file2 still exists, so does not disappear. Now that is hard link. Now if you go to content again, file2 still exists, nothing harmed, gone to it. Okay. Now, for the hard link, you cannot use it with directory. So let's say if I want to, link a particular directory, let's say one music, stuff like that, and I want to link that to a particular directory, call, let's say I want to call direct2 or something like that. I cannot do that. It's not, set hard link not allowed for directory. Now what is allowed for directory though is soft link. Now soft link, almost similar in theories, but quite different. So let's say you have a files here, have file1, which was your main files. Now that files, you link it to a particular location in your systems. Okay, and now you have file2, which is right here. Set file2s. Now these files link with this file, associate with this file, not link to that same location. See that? So the first example for this is it acting like a window shortcut. Now what was with the window shortcut? So as you know, maybe not familiar with the window shortcut, if say you're a folder or stuff of a application or something like that, or some files, and then you have to create a Windows shortcut to it and linked it to the original files, which you called it main files. So that is the kind of the gist of it, of what the soft link basically is. So different from mirror link, so it's basically like a window shortcut. So to know what exactly that means, let's check. Show you an example. So now, say I want to link a file. So for the soft link, which is symbolic link, you have /s for soft link, symbolic link, and then you put your source files, your original files. We call it the main files, which they technically apply the same. So we want to put names on it. Let's say for ems.txt, and you put the names of files. Let's say I'm name this files s.txt. We insert, nothing happened, but we ls again, ls, li. Now you see here, have file, our main file, which I'm calling file ems, that's tech, and this is our inode. Now the file that I linked to earlier, which is the files.s.txt, you see here is also said right here that it's pointing to that exact file.m.txt. And you since check this inode here. There's different inode, yeah, different, not identical inode, different inode. So you see here it generates kind of like the last name different here. So it's different between 0 and 3, so that their inode is exactly different. But what also interesting though is that when you look at the size of it, you see here the file m has 0, but when the files s has 9 bytes on it. So what you can see here is that similar to the actual Windows shortcut, these has a fixed size. So let's say I wanna, even though I wanna, let's say I wanna modify file ems.txt. Let's say I wanna say something here. Okay, say I modify that. And now when you look at the okay, I see here the m have 60 byte, but now the file.s only has 9 bytes still. So that's the size is fixed, it's not changing, even though this is changing. Now the reason that because the same with the Windows shortcut, this does not change because it only acts as a pointer to the original files and that specific locations. Also, speaking about shortcut, now if you were to delete a shortcut files, or say cd shortcut file, it still finds. Like the original file is still standing. But if you were to delete a original file or the main files, let's say one of rms, delete files, main files, called files rms, paragraph head still, file ems, delete that, and once I say ls again, you see that it's freaking red. See here it's red, and because the main file is missing, no longer linked, because it linked to nothing. And also, SoftLink does support, does work with the directory. Now say you can do the same with directory. Let's say you want to link s, and then link for the let's say music, and then you want to create a new directory, let's say called dk1, something like that. I don't know how to spell. Just insert, and you see there's two directories linking. See right here, is it linking? Actually, that's not okay. See, the directory is linking, pointing to a directory called music. Suck it, bitch.